Hello everyone, myself Professor Leena Prabhakar Zoge from DRGCOP Malkapur. Today I am talking about the topic thin layer chromatography. So in introduction, chromatography it is the technique for the separations of a mixture of a compound by passing it through a medium between two phases, one of which is stationary phases while another one is the mobile phase which is move in a definite directions. So there are different types of the chromatographic techniques. First one is the column or adsorption chromatography, in which stationary phase is the solid and mobile phase will be the liquid. Then second one is the partition chromatography, in which stationary phase is the liquid and mobile phase is the another liquid phase. Then third one is the paper chromatography, in which stationary phase is in liquid form and mobile phase is also in a liquid form. Then next one is the thin layer chromatography, that is TLC, which is in stationary phase which is in liquid or the solid form, and mobile phase it is in a liquid form. Then next one is the gas liquid chromatography, that is GLC, in which stationary phase is the liquid form and mobile phase is in a gaseous form. Next one is the gas solid chromatography, in which solid stationary phase and gaseous gas as a mobile phase. Gas liquid chromatography, that is GLC, in which stationary phase is in liquid form and mobile phase is the gaseous form. Then and last one is the ion exchange chromatography, in which stationary phase is in solid form and mobile phase is in a liquid form. So these are some types of the chromatographic techniques. After that we will move towards the definitions of the thin layer chromatography. It is also important technique for the identification and separation of a mixture of the organic compound. अगर हमको किसी ऑर्गेनिक कंपाउंड्स के मिक्सचर को जिसमें ऑर्गेनिक कंपाउंड्स प्रेजेंट है उसको अगर सेपरेट करना हो या फिर आइडेंटिफाई करना हो तो हम TLC मेथड चूज़ करेंगे, दैट इज़ द थिन लेयर क्रोमेटोग्राफिक मेथड. So it is useful in the different aspects like identifications of the components of a mixture which is using appropriate standards. Then second one is the analyzing fractions which is collected during the purification process, and third one is the analyzing the purity of the compounds. So these are the main key applications of the TLC or the chromatographic techniques. So principle of the TLC, that means thin layer chromatography. So principle involved in a TLC is the adsorption. Adsorption is nothing but the surface phenomena on which solute can be adsorbed on the another solute. So one or more compound are spotted on a thin layer adsorbent which is coated on a chromatographic plate. The mobile phase has a solvent flow through the because of the capillary action. The compounds with the greater affinity for the stationary phase moves slower rate and the compounds with a lesser affinity moves faster. जिसकी affinity कम रहती है towards the stationary phase वो क्या करेंगे, वो ज़्यादा से ज़्यादा move होंगे in upward direction on the mobile phase, and जिसकी affinity ज़्यादा होगी toward the stationary phase वो कम से कम move करेंगे in a upward direction. So identification of the component which is done by the calculations of the RF value for the each component. RF value means distance. RF value can be calculated as a distance traveled by the component divided by distance traveled by the solvent. This is the formula which is used to calculate the RF value. RF value is nothing but the retardation factor value. So advantages of the TLC over the proper paper chromatography. So first advantages it is that it is the simple method and cost of the equipment is low. अगर इसकी cost कैसी रहती है, कम रहती है, and it is the simplest method. Second one is the it is rapid technique and it does not consuming the more time like column chromatography. In third advantages that the separations of the mg of the substances can be achieved, means कम से कम सोल्यूट अगर हम लेंगे, कम से कम ड्रग सैंपल ले रहे हैं, उसका भी सेपरेशन अच्छे से हो जाता है इन केस ऑफ द TLC. Next advantages is that in any type of the compound can be analyzed. कौन से भी टाइप का कंपाउंड अगर हो, हमको एनालिसिस करना हो उसका, तो ये इजीली हो जाता है बाय यूजिंग द TLC मेथड. Then fifth point, efficiency of the separation. Very small particle size can be used which increases the efficiency of the separation. जितनी कम पार्टिकल साइज रहेगी उतना ज़्यादा उसकी क्या बढ़ेगी, इफिशियंसी बढ़ेगी ऑफ द सेपरेशंस की. ठीक है. एंड फ्लो रेट इज़ नॉट altered because of the particle size, since it is not a closed column, it is a planar type having thin लेयर ऑफ द एडसॉर्बेंट. ये क्या है, प्लेनर टाइप ऑफ द क्रोमेटोग्राफी है, जिसमें क्या कर रहे हैं हम, एक प्लेन यूज़ कर रहे हैं, दैट इज़ द ग्लास प्लेट. इट इज़ अ plane on which we can use the stationary phase or we can pour the stationary phase. Okay. And next advantages is the detection is easy and not tedious. जो डिटेक्शन रहता है वो कैसे रहता है, easy form में रहता है and not tedious form. Okay. Next advantages is that capacity of the thin layer can be altered, hence analytical and preparative separations can be made. In next advantages, we have to see that the corrosive spray reagent can be used without damaging the plates, and need less solvents, stationary phases, and time for every separation when compared to the column chromatography. It requires very less solvent as well as stationary phase, as well as it requires the less time consuming process, so we can use the TLC efficiently as compared to the paper chromatography. Next one is the practical requirement, how we can perform the TLC. So there are different types of the practical requirements are used. First one is the stationary phase, second one is the glass plate, third requirement is the preparations and the activations of the TLC plates, then fourth point is the applications of the samples, then development tank, then next one is the mobile phase, development technique, and detecting or visualizing agent. So these are the few components or the practical requirements for TLC. So in the first point, that is the stationary phase, so there are several adsorbent which can be used as a stationary phase. Some of the stationary phases, their compositions and the ratio in which they have to be mixed with the water or other solvents to form a slurry for preparing thin layer chromatographic plates as given in the following tables. So here are some adsorbent which is used as a stationary phase, or which is used to form a slurry as a stationary phase with the some solvents. So there is the composition. Next point is the glass plate. Second point is the glass plates. So glass plates which are specific dimensions like 20 centimeter multiplied by 20 means which has height 20 centimeter as well as width also the 20 centimeter, that is the full plate, and 20 multiplied by 10 centimeter, that is the half plate, into 20 centimeter multiplied by 5 centimeter, that is the quarter plate, can be used as a glass plates or as a supporting medium in case of the TLC, that is thin layer chromatography. So these dimensions are used since the width of the commercially available TLC spreader is a 20 centimeter. The microscopic slides can also be used for some applications like monitoring the progress of the chemical reactions. The development time is much shorter, like the 5 minutes. Then next point is the glass plate of the different dimension can also be used when the TLC plate are prepared without the use of the TLC spreader. In general, glass plates should be of good quality and should withstand temperature use for the drying the plates. Uh, these are the key points related to the glass plates. Then move to the next points, that is the preparations as well as activations of the TLC plates. The slurry, which is the mixture of the stationary phase and the water, is prepared by using the ratio mentioned earlier. After preparing the slurry, the TLC plates can be prepared by using any of the one of the following techniques like pouring, dipping, spraying, and spreading. So in the first pouring technique, the slurry should be prepared and poured on the glass plate which is mentioned or which is maintained on a level surface. The slurry is spread uniformly on the surface of the glass plate. After setting, the plates are dried in an oven. It is used for the spotting. The disadvantages of this, the uniformity in thickness cannot be ensured. हम generally pouring technique use करते हैं for the activations or the preparations of the TLC plates, but in this disadvantages इसका ये है कि हम इसकी uniformity as well as thickness को हम ensure नहीं कर सकते. So that is the disadvantages of this method. Second one is the dipping method or dipping technique, in which two plates, either of the standard dimension or microscopic slides, are dipped into the slurry and are separated after removing from the slurry and later dried. The disadvantage is that a large quantity of the slurry is required even for the preparing favor plate. डिपिंग में क्या करते हैं हम लोग, जो प्लेट रहती है ग्लास प्लेट उसको स्लरी में डिप करते हैं, बट इसका डिसएडवांटेजेस ये है कि लार्जर क्वांटिटी ऑफ स्लरी की इसमें ज़रूरत पड़ती है, और इवन क्या नहीं होता, इवन उसका स्प्रेडिंग नहीं होता है इन द डिपिंग टेक्निक. नेक्स्ट पॉइंट इज द स्प्रेइंग टेक्निक विच इज़ द resembling that resembles that of using a perfume spray on the cloth. जैसे हम परफ्यूम स्प्रे यूज़ करते हैं क्लॉथ पे, वैसे ही हम स्प्रेइंग टेक्निक में करते हैं, इन विच द सस्पेंशंस ऑफ द एब्सॉर्बेंट और द स्लरी इज स्प्रेड ऑन अ ग्लास प्लेट यूजिंग द स्प्रेयर. इसमें क्या करते हैं हम, एक स्प्रेयर में अपनी जो स्लरी रहती है, जो एब्सॉर्बेंट की जो स्लरी है उसको भर देते हैं और उसको स्प्रे करते हैं ऑन द ग्लास प्लेट बाय यूजिंग द स्प्रेयर. सो डिसएडवांटेजेस क्या है इसका, जो डिसएडवांटेजेस ये है कि जो लेयर ऑफ थिकनेस रहती है वी शुड नॉट बी मेंटेन्ड यूनिफॉर्मली ऑल ओवर द प्लेट. Next point is the activations of the TLC plate. So activation is nothing but the removing water or the moisture from and other adsorbent substances from the surface of any adsorbent. जो हम TLC प्लेट बनाते हैं उसमें हम क्या करते हैं, स्लरी बनाने के दौरान हम वाटर यूज़ करते हैं. सो वाटर ज़्यादा अगर मात्रा में हो जाए तो उसको मॉइस्चर कैप्चर कर सकता है वो, तो वो मॉइस्चर को इवेपोरेट करने के लिए या फिर रिमूव करने के लिए हम जो टेक्निक या फिर स्टेप यूज़ करते हैं उसको क्या बोलते हैं, एक्टिवेशंस ऑफ द TLC प्लेट. सो एक्टिवेशन कैसे करते हैं, बाय रिमूविंग द water or the moisture which is from the surface of any adsorbent by heating or at the high temperature so that the adsorbent activity is retained. The activated plate can be stored in a thermostatically controlled oven or in a desiccator and can be used whenever required. Next point is the mobile phase. So mobile phase, it is nothing but the developing liquid which travels up to the stationary phase. Upon that stationary phase and carrying the sample with it, it depends on the nature of the substance to be separated, that is the polar or the non-polar. Second one is the nature of the stationary phase used. Third one is the mode of the chromatography. Fourth point is the solvent used should be of the high purity, and the solvent used like petroleum ether, benzene, carbon tetrachloride and chloroform can be used for the preparations of the mobile phase. So next point is the spotting. So in the spotting there will be the 2 to 5 lines, 2 to 5 mLs of 1% solution of sample or the standard is spotted using a capillary tube or the micropipette. हम क्या करते हैं, एक माइक्रोपिपेट या फिर कैपिलरी ट्यूब से जो भी हमारा सैंपल है उसके 2 to 5 ml माइक्रो ml that means drop हम लेते हैं, and then spot should be kept at least 2 centimeter above the base of the plate, and the spotting area should not be immersed in the mobile phase in a developing chamber. The sample is applied on the narrow band and the width of the band must be narrow as possible. Next point is the developing chamber. So it is the use for the purpose of the TLC plates that is run in the mobile phase. Then after the mobile phase is poured into the chamber, it is closed with the lid. This is done to the equilibrate the atmosphere of the empty space in the chamber with the mobile phase. This is also known as the saturations of the TLC chamber. The edge effect occur when the solvent found in the middle of the TLC plates move faster than the edge of the plate. Next point is the detecting agent. So detecting agent, after the development of the chromatogram, the spot should be visualized. So detecting color spot can be done visually, but for the detecting colorless spot, any one of the following technique can be used. So first one is the non-specific technique or non-specific method, where the number of spot can be detected but not exact nature of the compound. For example, iodine chamber method, in which where brown or amber spot are observed when the paper is kept tank with a few iodine crystal at the bottom. Second one is the UV chamber for the fluorescent compound. When the compounds are viewed under the UV chamber at 245 nanometer or 365 nanometer, fluorescent compound can be detected. Next one is the specific method. Specific method reagent or the detecting agent, visualizing agent are the used to find out the nature of the compound for identification purpose. हम generally specific method use करते हैं, in which we can use the spraying reagent or the specific spraying reagent for detections of the visualizing compound or visualizing spot. Okay, so examples are the ferric chloride, for which phenolic compounds and the tannin can be identified. In hydrin in acetone can be used as a spraying reagent to identify the amino acids. Then Dragon-Dorf reagent is used for identifications of the alkaloid. Then 3,5-dinitrobenzoic acid can be used for the detections of the cardiac glycosides. 2,4-dinitrophenyl hydrazine can be used for detection of the aldehyde as well as ketone. Then how to run the TLC, how to run the thin layer chromatography. In the first step, prepare the developing container. In second step, prepare the TLC plate. In third step, spot the TLC plate. In fourth step, develop the plates. In fifth step, visualize the spot. In the first step, prepare the developing chamber, developing container. So take a bit a longer, take a beaker with the watch glass on the top, and required quantity of the solvent are taken into the beaker. Then cover the beaker with the watch glass and mix the solvent and keep them aside until the plate is prepared. In next point, prepare the TLC plate. Take a TLC plate and cut it into the required length as well as width. Now mark a line above the 1 centimeter from the bottom or from the baseline. On the line, place two dots at the equal spaces. Then in next step, that the spot the TLC plate, take the capillary tube and by the help of the heat make it into two, so that the end of the capillary tube will be thin. It helps to place a small amount of the sample of the crude drug. Then take the required solution and spot them at the mark point. In fourth step, develop the plate or developing the plate. So development of plate, in which we have to put the TLC plate carefully into the beaker. Then the solution should not touch the mark line. Then close the beaker with the watch glass and do not allow the solvent to run off the top of the plate. In next step, visualize the spot. Take off the TLC plates from the beaker carefully and mark the solvent from the front level. Then let it dry and spray the spraying reagent or different visualizing reagent solution and observe the spot and round it with the pencil carefully. In last, this is the last step of the TLC, that is the visualizations of the spot. So here you can see the solvent font at the top of the TLC plate and spot which is origin from the baseline, okay, from the 2 centimeter from the baseline, and there will be the another spot at the some distance, and that is the spot of the our crude drug or the our sample, which is the main chemical constituent. Okay, so we can calculate the RF value by the distance traveled by the solute, that means distance traveled by the crude drug divided by distance traveled by the solvent, that is the distance of the uh, solvent font from the main baseline. Okay, so this is the steps involved in the TLC. Then next one is the quantitative analysis, in which there are two techniques. First one is the direct technique, that is the direct technique, and second one is the indirect technique. In direct technique, densitometer is an instrument which measures the quantitatively Quantitatively, the density of the spots, when the optical density of the spot for the standards and test solution are determined, the quantity of the substance can be calculated. In second step, that is the indirect technique, in which in this technique the spot are cut into the portions and eluted from the solvents. So this solution can be analyzed by any conventional technique of the analysis like spectrophotometry, electrochemical method, etc. Then next point will be the qualitative analysis. So in which we have to calculate the RF value. So RF value, that is the retardation factor, it is calculated for identifying the spot. That is in qualitative analysis. RF value is the ratio of the distance traveled by the solute to the distance traveled by the solvent font. So RF value ranges from 0 to 1, but ideal RF value are from 0.3 to 0.8. The RF value is constant for every compound in particular combinations of the stationary as well as mobile phase. When the RF value of the sample and reference compound is same, the compound is identified. Okay, then last point is the point of this topic is the applications of the TLC. So TLC paper chromatography is more useful for the analysis of the polar compounds like amino acid, sugar, natural products. The different types of the application are listed above below. So separations of the mixture of the drug, of the chemical or the biological origin, plant extract, etc., as well as separations of the carbohydrates, vitamin, antibiotic, protein, alkaloids, glycosides, amino acids. These can be helpful for the TLC, or TLC can be helpful for the separations of the all these secondary metabolites as well as primary metabolites. Thank you.